All right. So if we all have everything we need, let's look at 34. So we're gonna look at these different situations. Julie babysits for her neighbor's baby and stuffs the $15 she earned into her purse. When she gets home, $15 is nowhere to be found. Must have fallen out. The Burton Pumas football team completes a pass and gains 12 yards, but on the very next play, the quarterback holds on to the ball too long, gets sacked, and loses their 12 yards. And Rolando is at the beach, digs a hole in the sand, and we all know what happens then. Someone comes along and pushes the pile back in. What do these have in common? How would we represent them? What would we do with the mat? Take like 30 seconds to a minute to talk with your team.
Taken out. 12 yards up, 12 yards down. Got 15 taken away. So BBS.
Not completing both. We do part of 8th grade and we do all of the 7th grade math. Like we skip certain things, but they get covered in other places. All right, who can explain this to me? Why we care about these situations? What they have in common? Annie.
They all start out like if you're representing this on like a number line or something. They all start at 0, and then they earn something or get something or dig a hole, and then something happens like she lost her money or like they threw the ball too long and they go back to where they started.
Yeah, so something happens and then is undone, and they go back to 0. So it's not that nothing happened, but there was no change in the end, right? Because what was done was undone. Very good. So that would be a 0, right? If on our expression mats we see 2 of the same thing on opposite sides, that would cancel out to 0. So different things on the same side, we know that these cancel out to 0, right? A positive x and a negative x, they cancel out to 0. But, and I'm going to kind of like skip over parts of this lesson to go a little quick today. We are going to skip 35 and look at 36. What is the value? And you probably won't need long. You can make it if you want to. What is the value combined simplified of this expression? Represent it in 3 different ways. So that's where you might have a slight challenge. I'll give you at least a minute. 3 different ways. I mean, until you need those, you can just leave them like that.
That's too awesome.
I mean, it's a good representation of the fact that the x squared tiles and the y squared tiles, and like, so this, there was a word in your book, and we'll come back to it, non-commensurate, which means like I can't line these up, right? It's like 5 and something left over. I can't line this up. It's like 3 and something left over. So this is a good utilization of it. It doesn't work perfectly. Make sure that stays with whatever bag it stays with.
That's like I saw this picture. Man, like 2,300. Oh no. 21,300 pounds
What's on the top? If we just talked about everything that's up there. Right? And on the bottom, Annie?
Negative.
Yeah, -3, or we could say the opposite of 3. So then, if I want to write this expression, I could just take what I had originally. I don't know why I disconnected there. And put my -3 with it, right? Just -3. Or instead of saying -3, I could say plus a -3. I can either say and I have 3 negatives, or I could say -3, take those away. But if I start to simplify, what's another way? Please make sure we're not just playing with tiles. I have a lot of people that are just playing with tiles right now. And we're not in the accelerated class to just like we can have a day building with Legos. Right now, we got to actually be writing things down and simplifying expressions.
We should have a discovery day Legos and just come and build Legos.
So if I start, we need a lot of Legos. If I start to simplify combine, Annie?
You could combine 2x and negative x making 1x, and 1 and -3 is -2, so you would end up with x minus 2.
So we have 1x and a -2. Or if I only combine the x's, I could have had 1x plus 1 plus a -3. Yeah, sorry, sometimes I don't lift my pen enough. And I could also, though, what if I throw a 1 up top and I throw a 1 down bottom? Does that change anything? No, because they cancel out, right? So I could actually throw another x up top and an x on bottom. Or an x squared up top and an x squared on bottom. I could do whatever I want with this, as long as they would cancel each other out. Now I could also put another x up top, or sorry, another 1 and a -1, and those will cancel each other out. So I could do a lot of things and actually not change anything. Questions? I don't want to be on this too long if people don't need it. So, capture this real quick. In 37, build them so that your representation does not match your teammates. You got to all agree that each of you has represented what's up there in most of these 3 different ways, but 3 or 4 different ways.
Sorted them out. Okay, what do we need?
Yeah, that's okay. What's not okay is you got nothing written down for this. Hold on, wait, you're spending more time playing with the tiles than you are taking notes. That's not true. So that hasn't been true today in class. So you have notes written down. Because I'm trying to figure out how that's not true. That's fine. Where's what we've done today? So, knock it off. If you can't handle the tiles, don't get them. If you can't not play with them, you gotta show that you're mature enough to be in this class.
Literally. Just like, do it what it says.
All it is focus, write what you're supposed to do, as opposed to playing with the tiles and ignoring when I say we should all be writing this.
There. I think that's right. There we go.
Guys, we have to come up with
Where's our notes for what we're doing right now? Like, when we wrote down the expression from the previous one and then we simplified it. Guys, if it's getting written on the board, it should probably be written in your notes. I have a lot of people trying to slip by with minimum effort in here. There is a path, and this doesn't happen like ever, but there is a path at the end of this year where you've not shown enough to complete the accelerated 7 class, and you just get credit for Math 7. And then you do things over again next year because you didn't master the 8th grade skills. I worry that some of you minimum effort people are heading down that path of like, I didn't get all these skills mastered because I put in the minimum effort. We're about to speed up even more second semester. Well, is that the connected one or is that a y? Yeah, that's a 5 or a negative 5. Sorry, I thought it was a y from back there. Because these are y.
Also, I did these too.
For B and C, we're going to write those out. A, you don't necessarily have to. I go honor system in this class. I just worry that a lot of people are taking advantage of that. Like, you chose to be an accelerated. If you don't put forth the work, that's a you problem. The me solution is switch you out of this class. That's the only way I solve this. It's because like 2 years down the road, if you're a minimum effort person, do you really want to be on the accelerated track in the honors courses? If you're minimum effort, you don't. Like, just make that decision. Now, I would love if we all did that. That'd be amazing. But Naya over here is trying to build a house of cards with her tiles. That's not what we're trying to do. And you're still an A, right? And your A is wrong, actually, what I can see right now. So that's why I'm slightly frustrated today. There are a lot of people, like, when I look at this lesson, I'm like, oh, should we use tiles, should we not? Oh, they like the tiles, we'll use the tiles. We don't have to be using these tiles. There's an option where we use a digital one, or there's an option where you cut them out of paper and have to do it. That's really annoying.
We're not trying to kill trees.
Right, but I got people who can't handle the physical tiles because they're too fun to play with. Nice. Relax. Thank you. In A, is there anything that needs to be done to it if somebody just handed you that expression algebraically and said, like, here you go, simplify this? Can we do anything to simplify A? Nothing can be combined. Why can't I combine things? Who's got that vocab word? Ian?
Because there's no like term.
No like terms. So, how did you make it in other ways then? What did you do to the expression to make yours different than the initial?
I mean, you just kind of mix it up a bit, like move it around.
You could move some of the tiles. So instead of having 3 X's on the negative side, have 3 negative X's in the positive side. Or split them up a little bit. So we can move tiles around. If we use 3 negative tiles for the X's, 5 positives, and a positive Y, they all have to be on the positive side. But if I want to use if I want to use positive X tiles, I just put them on the negative side, right? Because there's the opposite of what you see. That's how we make it look different. Now, B and C have work that can be done, so if you haven't written them down yet, please jot it down. I'll write it down again. The opposite of negative 2y plus 1. So if I build this just exactly how it shows, everything's on the opposite side. I use 2y tiles and a positive x, but they're on the opposite side. If I bring them up to the positive side, to the what it is side of the mat, what do they turn into? Is it 2y and a negative 1, exactly. So that's another way we could write it. We could write it as 2y minus 1. We could move some other things around, we could have a positive 2y and the opposite of a negative y. So if you wanted to get really weird, you could say y minus negative y plus a negative 1. We could distribute the opposite. We could say the opposite of negative 2y plus the opposite of positive 1, which is really weird, but there's lots of ways you can write this. Really, and this is where like infinity starts coming, there are infinitely many ways to write any expression. Because we're allowed to do anything we want as long as we follow the rules. So you could write this in infinitely many different ways. Yeah.
No.
Still trying to piece thoughts together.
There has to be a limit, right?
No. Think about it. I could keep pulling
Out of
in
this
tiles that
expression?
the 0 pairs. I can do 0 pairs all the. I could double, like if I do it on. So if this is like equal to something,
Okay, I was
then
thinking
it's
of
do it to
0
both sides. Right now it's just an expression. It's like saying how many ways can I represent 10? Well, I could do 1.99999999999 plus 8.000, and there's got to be a one. Like I could also infinitely many ways. But the idea of infinity is kind of too far for most of us,
Okay, I get it.
like myself included. If you think too hard about it. Yeah. C. Same type of problem. We can write it multiple different ways. So if you have not written it down yet, we have 2x and the opposite of x minus 4, or you can say 2x minus x minus 4. But because the x and the 4 are in the parentheses together, we do that first. Oh, wait, we can't. What do we do? What do we do?
The parentheses goes away.
So the parentheses goes away, and when I do that, we got to be a little bit careful here. This has to distribute, right? So if we built it, the x and the 4 negatives were in the bottom on the opposite region with the 2x on top. If we bring everything up, it all flips. So this distributes, and it becomes 2x, then what? A negative x, and then plus a 4. So then another way to write it.
3x plus 4.
Ooh, you get positive 2 x's, or 2 positive x's, and then a negative x now.
Minus 4. No.
You have 2x and 1 negative x. We make a 0 pair. Well, if you need to build it to look at it. When these values come up from the negative side, they all flip. Then a positive and negative on the same part of the mat cancel. Positive and negative on the same part of the mat cancel. Questions? That's really loud. I was jamming this morning. All right. Try. Now, you do not need to build 38. If you can't handle yourself, please don't. But write out what we see in A and B. Remember to write this exactly how they give it to us. This section is the opposite of something, whatever's in it. So the top is what it is. The bottom is the opposite of what it is. So like in A, if I look literally at what is there, I write every single piece. I have a positive x. I have 2 negative x's. Negative 2x. I have 2 negative 1s. And then I have the opposite of 2 negatives. Plus the opposite of a negative. Which is how I could write this. Because if I'm just going to say, and I have this, and I have that, and I have that, and I have that. That's what we have. And is always the addition. So then, Oliver,
was going to say something about how like it's the opposite of a negative.
Yeah. So that's part of the simplification.
When I was doing the ST math thing,
Yeah.
they had the thing where it was like determine where the number would be on the number line, and it was like the -7, and then like 7 more negative signs. And I would basically just think, well, if that's the 7 plus the one already on the 7,
Yeah.
if it's an even amount of negative signs, then it's a positive number. But if it's an opposite amount, then it's a negative. And that just made it super easy.
Yeah.
So because there's 2 negative symbols, it's the opposite of a negative.
So. Yeah. So then, if this is 2, what we just reasoned through, and the other constant tiles or 1 tiles are worth -2, then what does our constant become together? 0. And we can actually see that these could group up visually all because they're in the same region. They are opposites of each other, and we get left with a negative x tile, just one of them. So we have -1x plus 0, which can be simplified as just negative.
That's correct.
Try B on your own if you have yet to do so.
No, he's
They're
showing a
canceling
canceling
each other
out.
out.
Oh.
I was going to ask what I was showing. I'm never going to a movie with you guys ever.
I didn't do anything.
That guy dies at minute 43. So what I was highlighting up here, so if you, in the same region, you're like, hey, this is an x, this is a -x. Well, they fight each other, and they cancel out, so this gets removed from our expression. A +1 and a -1 can get removed from our expression. Then we've got the evil twin. So we have the -x and the opposite of the -x, which again are opposites. They're not on the same side, but they're, bless you, they're on opposite sides of the mat, which means they are opposites. They cancel, they equal 0. And once we do all of that, what are we actually left with, Zen?
1x plus 2. Or x plus 2.
Ooh, so we have x plus -2 actually, because that's a positive x, so those are -2s. Ah, we have the opposite of that stuff. So we do the opposite of the x, the opposite of the -2, so we get -x plus 2. We could also just bring these up. If you bring them across the dotted line, they flip over. So if I bring them up to what they are, not that we're bringing them out, but we're bringing them up. And we flip. Preguntas. Questions. Preguntas. Questions in Spanish. It's a really fun, it's pre, like with the rolled R. Preguntas. So put your tiles away, please. Because we don't need them anymore. Not quite. Close. We just don't need your tiles anymore.
Silently not. You're a low. So like, when you're homeless, you're like, oh,
Mine, I really like Ocean's 11. There's some British comedies
I'm
where
like,
they're
oh, I'm fine. I still have a couple dollars to make.
yeah. There's some contemporary movies that I really like.
Wait,
Though.
dude, really?
Like
That happened?
like Interstellar, movies about space. Hey guys, so one bag feels pretty light, and there's also just tiles scattered in this box. If we can't respect our resources, we can't use them. So we need to make sure that, like, if a bag rips, you gotta let me know. If you're mixing tiles up, let me know. It's not like you're gonna be in trouble, but like, I've got translucent tiles that are now mixed with like regular non-translucent tiles.
Maybe
That's
that's
like,
why that
we need to respect these materials more than we are right now. So I think we're kind of having some mixing and things just based off not caring. Please write these expressions in your notes. We're just algebraically, so without modeling,
We're great at
just algebraically going to solve these. So we're going to do what we can to simplify, combine like terms, and make this easy to look at.
Easy.
If we look at what A is telling us, we have a 3x, and we have, they don't put an addition there, but we could put a plus right up here, because they have and the opposite of 2x and 4. So the first thing we do, please draw these arrows, because at some point I will be marking off on your guys' tests, and I will be drawing these arrows, and then I will say I told you so because I asked you, please draw the arrows. That makes sure you don't forget to distribute. Even once you're a pro at this, I still say draw the arrows. Because I've seen adults forget to distribute to a term, and it screws everything up. Once I do the distribution, my 3x doesn't change at all. The opposite of 2x, the opposite of 2x. The opposite of 4, the opposite of 4. I could write these as plus negative 2x, plus negative 4. So if I wanted to be very detailed, I could write it like that. We don't have to, but we could. Then what do we do? Well, how? Yeah. There are some zero pairs. There's 2 0 pairs there, exactly, and we're left with x and nothing to be done with those single tiles, so x plus a negative 4 or x minus 4 if you prefer the subtraction instead of plus the negative. Simplify part B.
Oh, I just wrote down one X.
B is a bit harder.
Isn't it? Why?
Well, there's just also more numbers. So if we wanted to, we could write this as 7 and. So 7 plus the opposite of 4y minus 3. Yes. It all depends on how we read it. How we look. It is either. It is how we read it. Even divisible by 2. Evenly divisible. It breaks in half.
Wait, but then what would be odd? Because that would technically be divisible by 1, wouldn't it?
No.
No, it would be divisible by 3.
No.
No, because
Yeah.
Odd is like atypical. Like if something is odd, it's not just meaning it's not divisible by 2. It means like it's not something like, oh, that's an odd duck. Like he doesn't look like the other ducks. It's like that's a turn of phrase. So odd essentially in math just more so means not even. Oh, it's an odd number as opposed to the even numbers. The evens are nice. Oh, that's an odd number. Oh, he's an odd guy. The opposite of 4y, negative 4y, or minus 4y. The opposite of -3 is a +3. So check if you have what I have in purple up there. Then look for like terms. If I look for like terms with the 7, oh, I don't want purple. Purple rain. I'm glad that anybody knows that. A 7, what goes with the 7? The 3 and the -4. Make sure you're taking the sign in front of it because that belongs. Now this is not a minus. People always try to do this. We could read it as a minus, but it belongs with the 4. That's a -4. So if I've got positive, how much positive? 10. 4 negatives bring me back to 6.
Wait. I thought that was a minus, not a -4.
Yes, it is either.
Oh, wait. I'm confusing myself.
We could read it as minus, or we could read it as and a -4. So, Ian, give me your eyes. Give me your eyes for a second. I could read this as 7 minus 4y. I could read it like that. Or I could say I have 7 and a -4y and a +3 and a +2y and a -4. Or and take away 4, but that's not quite as useful if we're thinking in the physical sense of what do you have. And I've got a -4 or 4 negatives. So if I've got 7 positives and 3 positives, I've got 10 positives. Then I've got 4 negatives, bring me back to 6. But I could also say -4. We just are now talking slightly different. Okay, then my y values, I have a -4y, +2y. We end up simplified -2y and +6. Take the rest of your time to work on your homework. We'll all done.
That's something we all need.
No, because the opposite of -3. Because it's the opposite of everything inside the parentheses. Yeah, I almost wrote it wrong actually. So the opposite of negative becomes positive. Guys, you've got like 7 minutes to work on your homework. You can bust out a few of these problems.